Now let's go to see how we can connect all these 16 keyboard keys to our program. In early exercise we were only using these upper 4 keys from our keyboard, but now we are going to use all these 16 keys from our keyboard. And what we need to do now is that we have to, earlier we were earthing this one line here, and as we were not using these other lines. But now we use the P port here, and we use the P port to controlling the rows from our keyboard. The C port remains as it was earlier. We are using C port as input and P port as output, and we are somehow earthing these lines on time to time here to scan whole keyboard. And here's the wiring diagram also to our keyboard. Here are these port numbers, P port numbers and C port numbers, where we connect the wires from the keyboard. Here's the same picture as earlier, but drawn in different way. So here we can see that the P port P0 goes to the lowest row and P3 goes to the upper row here, and C port remains as it was earlier. So how now to do this scanning, how to change the earthing for different rows? Here is the basic idea what we will do. Here are different states. There are 4 stages and we will have 4 rows here. So if we control the P port in that way that the lowest bit will be 0 and the rest bits will be 1s, so that means then that this line here is plus 5 volt, plus 5 volt, plus 5 volt and 0 volt. And now if this has been put it to 0, logical 0, then we can read the lowest keys as earlier. Okay, when this has been read, then we will change to state 2. So we are now putting 0 volt here. Here is plus 5 volt and plus 5 volt are here. So now we can read this row here. And same way to change 0 here and 0 here, we can read all these rows. And of course, each time when one row is activated, we have to check that which key is pressed in that column direction. And how to do this? How we can change the status of P ports? We could take so-called mask variable, and in mask variable we can output the mask variable to P port, and then the value of the mask variable will control that which line is up or which line is 0. For example, if we take a mask variable umask and put the starting condition for that in that way that all the bits are logical 1s except the lowest bit. So this is the mask variable start condition here. All the bits are 1s except the lowest one. And now if we send this mask variable value to port P, then of course the P port statuses are the same as the content of the mask variable. So it means that in the start condition this lowest row is 0 and these are logical 1s. And then if we shift the bit in the mask variable to left side, so then the B1 will be 0 and the rest bits will be 1s. And then again, if we output this state 2 mask variable value to P port, then this line will be 0 and the other lines will be 1s. And when we are circulating this 4 times, we shift the bit to left and output the status of that our mask variable to output port. Then we can generate all these 4 stages, and it means that each of these roads will be activated at time. And here's the small code example how we could do this. This was our start condition here. So then we will put the start condition at the begin to our we initialize our mask variable here with the start condition, and then we will use the for loop to change this, to count these stages and change these stages here. We will have 4 stages, so we will start from 0 until the count variable will be 3, from 0 to 3. And here we will send the mask variable value to P port, and here we are shifting the mask variable pitch one phase to left side, and here we need this command when we shift the pitch to left side, there will be 0 bit coming to lowest bit, and we have to correct that by putting the lowest bit to 1. So then we can now with this simple code example we are able to generate this kind of stages and get this bit combination to be outputted to beat board. And with that simple code example we were able to activate each of these rows at time. So we can change the row. We can change the activated row with that small code example. And then let's see next how we read this whole keyboard. We need to read these columns here at time, and we have to control the row lines at time. And we have 16 keys here, so that means that we have to read the state 16 times. Then we have been reading through whole keyboard. Here's the code skeleton idea how to do that. This is not the final code, so you have to add some functionality of course here, but this is basically the idea how you can do that. So here is there are 2 for loops. The internal for loop is here, and that loop will read the column status. That's basically the same idea that you tried also in exercise 9. So we are going through from 0 to 3 4 times, going through this loop, and we will use this ESC mask here, which is the column mask. And in here we are checking that if the column mask will match the C port input status. We are checking that in which column the key is pressed or is it not pressed. And the outer loop here, that loops will control the rows. It will activate each row at time. Here's the umask variable that will control which row we will activate, and in here we will output that umask variable to P port. That will activate then one of those 4 lines of our keyboard. And if we do this 4 times multiplied 4, then the if will be then done 16 times. So we can check all these keys from our keyboard. So here's your exercise 11.1. So the idea is to read all these 16 buttons. And now you are utilizing the information that you have been tried earlier. So the keyboard reading could remain same, almost same as you have already tried, and we just went through how to configure and how to use the keyboard to activate row at that time, each row at time. And now in the first exercise we were using this manual grounding, but now we use this our software through this keyboard to grounding those rows at time. So try this exercise with your own way, and in next exercise there are more details what kind of functionality you should be coding to read the keyboard. And here's the exercise 11.2. Create one function that will be type of character and name is hit keyboard. So the idea is that this function will return the number of pressed key. There are 16 keys, so we need numbers from 0 to 15. And if there are no keys pressed, then return value minus 100. If there are keys pressed, then return the pressed key number. But if no keys are pressed, then return minus 100. And the next function is pressed keyboard. It will return the same number if the key is pressed, but it also waits until the pressed key is released. So this will return the number when you released the pressed key. And of course it's worth to use this hit keyboard by generating this pressed key. So you don't need to generate double code, but instead inside this pressed key function you should use the functionality of this hit keyboard function.